Welcome back, Calculus. Our objective for today is going to be to apply L'Hopital's rule for limits. I'm going to force a pause on your screen. You know what to do from here. Okay, I'm going to force another pause on your screen. Can you write and find me that limit, please? And then go ahead and hit continue when you're ready to see the answer. All right, we should have gotten 1/6. That was kind of the pre-calc way of doing it. Make sure you do show that it was 0 over 0, right? So that means do more, and the do more I did was factor and cancel, okay? Which totally works. So I'm going to show you another way as well that's really nice for perhaps more complicated functions. So can you go ahead and write that limit one more time, and I'm going to show you a different way. Okay, so here's my new way. First of all, we have to show, yes, this is still 0 over 0. So what I'd like for you to do now is, let's rewrite the limit. What is the derivative of the numerator? It's 1, right? What's the derivative of the denominator? 2x. All right, try the limit now. Plug in 3 for x now. We get 1/6 again. Okay, so that is L'Hopital's rule. So essentially all we did was first we had to show it indeterminate form, right? It was 0 over 0 originally. So a new way to find an indeterminate form is just take the derivative of the numerator over the derivative of the denominator and try the limit again at that particular x value. Now we need to make sure we do not confuse this with what rule? Don't confuse this with quotient rule, okay? So if I asked you to find the derivative of that, I would need quotient rule, yeah? But if I asked you to find the limit as x approaches 3 of that, I can use L'Hopital's rule, okay? So just something to be mindful of. Don't switch the two. So this is Mr. L'Hopital, French mathematician from the 17th century. And this is what his rule says. So if you've got the limit as x approaches a of f over g is indeterminate, so 0 over 0 or infinity over infinity, then you can compute the limit as x approaches a of f prime over g prime. So I'm going to force a pause on your screen. Can you please write this in your notes? All right, so I'm going to prove this for you so you don't just have to take my word for it. You do not have to write this down if you don't want to. If you want to just sit back and watch the proof, that's fine. So what we know is we want to find the limit as x approaches a of f of x over g of x. And we know this is indeterminate. We're going to assume f and g to be continuously differentiable. So in other words, when I plug in a for f and for g, I get 0, right? I get an indeterminate form, okay? So here's how I'm going to work with this. Well, I can take the limit as x approaches a of f of x minus 0 over g of x minus 0. I haven't changed a thing, right? Subtracting 0 doesn't change anything. Well, I can make a substitution now because 0 is equal to g of a as well as f of a. So what I can do is f of x minus f of a, because f of a is 0, again, not changing anything. And in the denominator, I have g of x minus g of a. So again, g of a is 0. All right, so now what I'm going to do, keep that limit. I'm going to go ahead and divide numerator and denominator by the same thing, because again, that is legal. So I'm going to take my numerator, divide it by x minus a, and then do the same thing with my denominator. Okay, and now the limit of a quotient is the quotient of the limits. So I can take this limit and apply it to here and here. Well, if I do that, maybe you'll notice that is method 2, right? So the limit as x approaches a of f of x minus f of a over x minus a is f prime of a. And the limit as x approaches a of g of x minus g of a over x minus a is g prime of a. And this is equal to the limit as x approaches a of f prime over g prime, again assuming f and g are continuously differentiable. There we have it. So a couple years ago, I got to grade one of the L'Hopital questions on the AP Calc exam, and we have a lot of really nice drawings regarding hospitals. One of the comments we got a lot was on the spelling, and so I want to make sure you know you can spell this different ways. So if you see it spelled differently, you know it's not a misspelling, it's just a different way to spell it. So in the 17th and 18th centuries, the name was commonly spelled L'Hopital with an S, And L'Hopital himself spelled his name that way, but French spellings have since been altered and the silent S has been removed and been replaced with the circumflex over the O, here, that piece. And the former spelling is still used in English where there's no circumflex. So you may see it with an S, so then it looks like hospital, but it's pronounced L'Hopital. The S is silent. So you may see it with an S or not, or with a circumflex or not. All right, before we try some examples, I want to pause and do some derivatives review, because if we aren't doing our derivatives correctly, we're not going to be able to do L'Hopital's rule correctly. So I'm going to force a pause on your screen. Can you please copy these and try them on your own? Press continue when you're ready to see the answers. All right, answers are on the screen. Go ahead and pause if you need to make any corrections. Remember, for e to some power, that you take the derivative of the outer, which is just going to be itself, and then don't forget to multiply by the derivative of the inner. So in this case, the derivative of negative 1x is negative 1, okay? All right, example 1, find the limit. Before using L'Hopital, you must check to see if you have an indeterminate form, so 0 over 0. I'll force a pause on your screen. Can you go ahead and copy that limit, and then we'll work it together. Okay, so do we have 0 over 0? Well, e to the 0 is what? It's 1. 1 minus 1 is 0, so I definitely have 0 in the numerator as well as in the denominator, right? So that means I can apply L'Hopital's rule. Do not drop your limit. So L'Hopital's rule says derivative of the numerator over derivative of denominator. Well, derivative of e to the 2x is 2e to the 2x. Derivative of 1 goes away. And then derivative of x is 1, right? So now plug in 0 for x and try the limit from here. So I have 2e, 2 times 0 is 0, over 1. E to the 0 is 1, so my final answer is 2. All right, I'm going to force another pause on your screen. Can you copy what I have, and we'll work this together. All right, so make sure we have 0 over 0. Numerator is certainly 0. Cosine of 0 is 1, and 1 minus 1 is 0. Okay, so we are allowed to apply L'Hopital's now. So I have, again, don't drop your limit as x approaches 0. Derivative of the numerator is 2x. And then derivative of 1 goes away. Derivative of cosine is negative sign, but you already have a negative in front of the cosine, so negative, negative will take us back to positive sine of x. All right, now let's plug in 0 for x. But now I'm getting 0 over 0 again. Please don't put that this is equal to 0 over 0, right? So I have a problem. What do you think I can do? Let's apply L'Hopital's rule again. Okay, so round 2, I've got limit as x approaches 0. So apply L'Hopital's rule again. Derivative of the numerator is 2. Derivative of the denominator is cosine of x. So now, plugging in 0, I just have 2 in the numerator. Cosine of 0 is 1. So final answer is 2. All right, so your assignment is going to include limit problems, some of which you'll want to use L'Hopital's rule, some of which there are better methods to use. So I'm going to force a pause on your screen. Go ahead and copy example 3, then I want to talk about how I would do this question. All right, I'm hoping that this looks familiar. This is method 1. So to find the formal way of finding f prime of x is the limit as h approaches 0 of f of x plus h minus f of x all over h, okay, which is what I have here. However, in this case, f of x is what? What's my function here? It's ln of x, okay? So this limit is the formal way, or the pre-calc way, the long way of saying what is f prime if f of x is ln of x. Well, my answer here would be 1 over x, okay? And that is my final answer. Okay? You can do this using L'Hopital's, but it gets it's quite a bit of mental gymnastics because you have to think of h as your variable and x as a constant, which is not an easy thing to do because x is very rarely used as a constant. So if you want to see that done with L'Hopital's rule, we can certainly do that in class. All right, last one. Will you please write this one in your notes? Okay, so we've got limit as x approaches infinity of ln of x over x. We could apply L'Hopital's rule because this is in an indeterminate form, infinity over infinity, but when x is approaching infinity, I think it's easier to think of think in terms of Bobo bot needs DC. Okay, so which kind of piece, I guess, of Bobo bot needs DC do you have in this case? You have Bobo, bigger on bottom, because logs grow very, very slowly, okay? So bigger on bottom, 0, and that's all the work you need to show for something like that. And if you need a reminder of the slowest growing to fastest growing functions, I've got them on the screen. So the previous one, we had ln of x, a log, over x, which is a polynomial. So polynomial grows faster than a log, so we had bigger on bottom. Okay, so I'll leave you with this. If you need to rewrite it, feel free to, and I will see you all next time.